lesson 79 is called De Moivre's theorem, and we're also going to do roots of complex numbers. Now, De Moivre's theorem is just a quick little way to go from polar form to rectangular. All right, so we've already done some of this. If we were asked to find what 2 CIS of 30 times 5 CIS of 70 is, you know that what we do first is the 2 and the 5, we multiply those together, we bring the CIS together, or along with it, and then 30 plus 70 gives us 100 degrees. So we'd have 10 CIS of 100. Now, for that, if it just says to leave it in polar, there's our polar and we're good to go. All right. If they ask you to do it into rectangular, which we'll do on the next page, then you're going to have to do a little bit more work. But we'll just leave this in polar for now. If we've got 4 CIS of 45 degrees raised to the third power, well, that's kind of like saying 4 CIS of 45 times 4 CIS of 45 times 4 CIS of 45. Well, what happens with that is really what we do to find that number out in front. We take 4 cubed. Well, 4 cubed is 64. CIS of, and then to find this number, which remember it's the degrees, what we did over here is we added these two together to get this 100. Here we're going to take 45 plus 45 plus 45, which gives us 135 degrees. All right, so for this first number, we take the number to the power. To find the number, the degrees afterwards, we take the number of degrees we started with and add it, or multiply 45 times 3 to get that 135 degrees. All right, for the next one, a little bit more complicated. Now we do have to use De Moivre's theorem to find 1 minus I squared roots of 3 to the 7th power, and then we have to express it in rectangular form. All right, so to use De Moivre's theorem, first thing we have to do is we have to put it into that CIS format. So for this 1 minus I squared root of 3, we have to graph that out. And you guys know this, the x-axis would be our real axis, our y-axis is our imaginary axis. We come to the right 1 and then down negative square root of 3. And then we see that this ends up being a 2 here because what we have is we have a 30, 60, 90 triangle. All right, so that 30, 60, 90 triangle there. Then, since our reference angle is 60, we have to find the entire angle here, which would be 360 minus that 60 to get 300. And our hypotenuse is always that number out in front. So this 1 minus I squared roots of 3 ends up being the same as 2 CIS of 300. All right, then we have to take it to the 7th power. So we have to take 2 to the 7th, which is 128. And then to find the angle, we take our angle, this 300, times 7 to get our 2100. All right, from there, we at least know what our hypotenuse of the new triangle is going to be. This 128, we can leave that out in front. We're not going to deal with that for a while, but we do have to figure out what the CIS of 2100 is. Well, 2100, we need to get that down between 0 and 360. And if we take 360 times 5, we end up getting 1800. So if we subtract 1800 from that 2100, we end up with 300 again, which would give us this exact same triangle. This is one of the rare cases where this would actually happen. If this were a 6, it would not work out that way. If this were an 8, it would not work out that way. It just happens to work for this one. So what we're doing here is we're using this triangle again. So we've got 128 out front here, and then remember this, the real part is dealing with the c, which is the cosine. Well, cosine of this triangle is 1 over 2. So we'd have 128 times 1/2, which would give us 64. And then our second part is the imaginary part, which goes with this s, which is the sine. So sine of this triangle would be opposite over hypotenuse, negative square root of 3 over 2. So we would take 128 times I times negative square root of 3 over 2. Multiply all that together, we get negative 64I square root of 3. All right, so there's our final answer there, 64I, or 64 minus 64I square root of 3. All right, now most of the time, these two numbers are going to be the same. Not always though, like on the next one. All right, so first thing we have to do here, it says find negative 3 minus 3I to the fourth power expressed in rectangular form. So we got to put this into CIS format, which would mean back 3, down 3, which means these two are the same, which means we've got a 45, 45, 90 triangle. This ends up being 3 times the square root of 2. All right, so we've got 3 square root of 2 here as our hypotenuse. That number goes out in front. And then we've got CIS, and then we've got 225 degrees here. All right, 225 degrees times 4 would give us our degrees afterwards, which would be 900. And then our hypotenuse, we have to take and raise it to the fourth power. So 3 to the fourth is 81. Square root of 2 to the fourth is 4. 81 times 4 is 324. So this ends up being 324 CIS of 900. Now from there, what happens is if we need to drop this down in between 0 and 360 degrees, this would be at, we would subtract out 720 degrees. So 900 minus 720 would give us 180. All right, so I'm drawing another graph here. All right, 180 would put us over here. All right, so we're right here. Cosine would be the adjacent side over the hypotenuse. Well, the adjacent side ends up being a negative 1 here. Over the hypotenuse is 1, so that's why we have a negative 1 here. For the imaginary part that's dealing with sine, that's the opposite side. That's how much up or down we go. We don't go up and down at all, so that's why this is a 0 here. Multiplying these together, 324 times negative 1 gives us negative 324. 324I times 0 ends up giving us a 0 here. That's why it's negative 324 there. All right, next page. Find the 5 roots of 32 CIS of 60. Now, to be honest, you guys are going to like these. These end up being on the simpler side. The 5th roots of 32 CIS of 60. First thing we have to do is we got to find that hypotenuse, kind of like what we did back here for some of these. We found the hypotenuse right away. Well, to find the 5th root of that, we just take the 5th root of 32, which ends up being a 2. And then we're going to put the CIS down. Now we're going to have 5 of these because that's what it says. Find the 5th root. There's always going to be the same number of roots as what it says to find. So if you wanted to, you could write down 5 of these right away. There's half of the problem right there. Okay, now we got to find the angle measurement that's after it. So we've got 60 degrees. We take 60 divided by 5. Ends up giving us a 12 there. All right, now we have to find these other 4, which these other 4 are always going to be different. The hypotenuse can be the same, but the angle measurement is going to be different here. So what we have to do is we've got to figure out how many degrees we're going to add to each one of these. All right, well, there are 360 degrees in a circle. We need to divide that by 5 because we're looking for 5 roots. And when we do that, we get 72 degrees. And what we do with that 72 is we're going to add it to the original. So 12 plus 72 gives us 84 degrees. All right, 84 degrees plus 72 gives us 156 degrees. All right, from there, 156 plus 72 gives us 228 degrees. And then 228 plus 72 gives us 300 degrees. Now, one way that I like to check this just to make sure, I'm going to add another 72 to this 300, and I would end up with 372 degrees. If we subtract out an entire circle, so 372 minus 360, we end up back at the original. That should always happen. All right, so we're back to a 12 there, so we're good. There are our 5 fifth roots of this 32 CIS of 60. All right, sometimes though they don't put it into CIS format, so we have to do that first. Find the third roots of negative I. Well, for that one we have to graph it out. Negative I is going straight down here, so that would give us a radius of 1. Remember, your hypotenuse is always going to be positive, so that's why this number is going to be positive here. It's always a distance. So our distance here is 1. CIS, if we go all the way around the circle, we're to 270 degrees. So we've got 1 CIS of 270 degrees. So to find the third roots of that, we take the third root of 1, which is 1, and then we can write down this 1 CIS for all 3 of these. To find our first angle, we take our original, our 270 degrees, and divide it by 3. So we get our 90 degrees up here for our first angle. Alright, so we've got 1 CIS of 90. Alright, to find the other 2, we got to figure out how much we're going to add to that. So 360 degrees in the in a circle there, divided by how many we're looking for, means 360 divided by 3 gives us 120. We're going to add 120 degrees to the previous one. So 90 plus 120 is 210 degrees, and 210 plus 120 is 330 degrees. If we added another 120 to that, that'd be 450 degrees. 450 minus 360 gives us our 90 degrees again. So we're back to the original. So nice easy way to check to make sure that your angle measurements are correct. So there's our 3 answers for this next one. For our last one, we need to find the 4 fourth roots of 30 CIS of 30 degrees here. All right, now the numbers are a little bit more messed up here, but you do the exact same thing. We have it in CIS format. Now we just got to find our first one. We have to take the 4th root of 30, which is not a nice number, but use the calculator. We get 2.34. And then we can write down our CIS. So that's how I start every single one of these. There's my 4 fourth roots. All right, 30 degrees. We have 4 of them. 30 divided by 4 is 7.5. All right, it's a decimal, it's okay. All right, we can keep rolling with that. Then from there, we need to go 360 degrees divided by 4, the 4th roots, which gives us 90. So we're going to add 90 to our first one, and then we're going to keep doing that for the rest of our answers here. So 90 plus 7.5, 97.5. Next one would be 187.5. And our last one, 277.5. Add your 90 degrees, we'd get 367.5, which is the same as 7.5. All right, that will get you through the majority of lesson 79.